The history of the atom. The idea of the atom has a very long and complex history. Their existence was first proposed in the 400s and debated amongst the Greeks. It was then brought back in the 1700s by several researchers that we'll talk about. Then in the 1800s, parts of atoms, or subatomic particles, were studied by several other researchers, and all of this culminated in a modern understanding of atomic theory. You'll learn much more about atomic theory in chemistry and physics class, but to understand how organisms work, you need at least as good an understanding of atoms as that of the scientists in the early 1900s. So we'll be studying what they discovered about atoms, and then you can learn the rest about atoms later in your high school and college career. The word atomos means indivisible in Greek, and the term was coined by Democritus. Legend has it that this ancient Greek philosopher was sitting in the foyer of his house while his servant was baking bread in the kitchen, and he took a deep breath in and... Oh, how delicious is that bread. Wait a minute. How am I smelling that bread? The bread is in the kitchen and I'm in the foyer. That must mean that there are small pieces of the bread that are floating through the air from the kitchen through all the rooms in my house to the foyer and then up into my nose for me to detect them. What shall I call these small pieces of bread? I'll call them atoms. Small, indivisible pieces of matter. It was such a logical idea that many other Greek philosophers really liked it, such as this guy named Plato. Amongst other things, Plato really liked shapes, and he believed very strongly in our powers of imagination. So if we could picture something in our minds, then that might make it true. And he used his mathematics to imagine what atoms might actually look like. For example, since fire burns, he thought that fire might have very sharply shaped atoms that would hurt you when they touched you. And because Earth is very good for building, its atoms were probably cube-shaped, just like bricks. I think Plato's idea was rather clever, but his student Aristotle did not think so. He said, "Plato, where is the evidence for your idea? Yeah, it works out mathematically, but how can we see or detect cube-shaped atoms? I don't think that atoms exist because there's no evidence for it." Aristotle was one of the first real scientists because he believed that you needed to be able to detect something by sensory input, in other words, using your senses, before you believed it. Since in his day and age there was no way to detect atoms, he said, ignore all of Plato's atom ideas, that's totally ridiculous. Instead, let's think about something we can feel. We can feel if things are hot, wet, cold, or dry, so perhaps the world is just made of 4 substances, based on how hot, wet, cold, or dry they are. If something is wet and cold, then it's made of water. If something is cold and dry, then it's made of earth, and so on. He called these 4 substances elements and believed that all substances in the universe were made of some combination of these 4 elements. He even used his idea to explain gravity long before the idea of gravity existed. His version of the idea was called natural motion. That is, all elements will move until they assume their natural position in the universe. So Earth had a natural motion to exist only in the middle of the universe. And its natural motion was even stronger than that of water. So if you threw a stone into a lake, because of its natural motion, his explanation was the stone would drop right to the bottom of the lake until it hit the earth, until it achieved its natural position. Air was next, which explained why if for some reason there was a little air bubble that made its way underwater, that it would move upward until it rejoined the air. Fire was last, which to Aristotle explained why a flame always reaches upward towards the sky. A pretty creative idea for someone who had no idea what the term air density meant. Since then, science has come up with much better explanations for how substances move. But Aristotle's legacy is still important. He was the first one to decide that we need to base our explanations on evidence, just like you guys do in lab today, over 2,000 years later. I wish Aristotle had had the chance to travel into space. Since he was on Earth, he thought that this candle flame was reaching up because it wanted to reach upward, that there was a natural motion in which fire always moved up. However, if he could go into space, he'd see that candle flames in space burn in this round shape, and he might have reconsidered his ideas. It was almost 2,000 years before Aristotle's ideas which were promulgated by the Catholic Church, were finally overturned. This scientific revolution was instigated by the discoveries of two French chemists, Monsieur and Madame Lavoisier. At that time, and even today, most people assumed that when an object rusts, it is breaking down. In other words, it is losing mass. But the Lavoisier were the first to challenge that assumption and actually weighed objects when they rust, finding that the rusted object is indeed heavier. This finding completely baffled them and other scientists of the time. Some scientists assumed, sort of like with spontaneous generation, that the rust must be coming out of nowhere, and that the matter, the material of the rust, was being created as the metal rusted. But the Lavoisier had a different idea, and thus set up a slightly different experiment. What would happen if they let an object rust in a closed container? To the surprise of many, the object that rusted in a closed container, including the air around that object, weighed the same both before and after the rusting had occurred. From these results, the Lavoisier developed their law of conservation of mass, which states that mass can neither be created nor destroyed. That rusting object wasn't getting matter out of nowhere, it was actually extracting matter from the air. And if matter couldn't come out of nowhere, that must mean that air, the stuff that got trapped inside the bottle, must be made of matter. That was a difficult pill to swallow back then. It's even a difficult pill to swallow right now, because if you look at the air right in front of your face, it's totally clear. Anyone with a healthy sense of skepticism has to wonder, really? Is air really made of something? It was then that an English gentleman named John Dalton made a very important connection.
I'm bringing atoms back, yeah. They are small particles that can react, yeah. In set proportions and whole numbers that, yeah. Show elements have their own atoms whack. Take it from the Greeks.
So thank God John Dalton studied really old, dead Greek guys, or else he might not have had this idea. But in observing the chemistry that was being performed by scientists of his time, he felt that the idea of atoms could actually explain what these scientists were observing. For example, when scientists studied compounds, those are substances made of two or more types of atoms, they found that they needed to add, say, 2 parts of hydrogen to 1 part of oxygen in order to make water. That made them think, oh, maybe water's made up of 2 pieces of hydrogen and 1 piece of oxygen, just like H2O. They couldn't ever get 2 parts of hydrogen to combine with 1.5 parts of oxygen. The parts always came in whole numbers. So that made him think, okay, maybe all of matter is made up of small particles that cannot be divided, but they can react, and react in set proportions. Future scientists would build on this idea by studying different types of atoms or elements, but that's a story for our next video.